side congruence tells us that two triangles are congruent if their corresponding sides are congruent. So if I have two triangles, well, we'll pretend that's a triangle. Okay. We would need AB to be congruent to DE. BC has to be congruent to EF. And AC has to be congruent to DF. You need all three. Okay, and now we're going to prove two triangles are congruent. We're going to use a two-column proof because I think that those are the easiest proofs. There are two-column proofs, there are flow proofs, and there are paragraph proofs. Okay, the two-column proof, you have one column for statements and then another column for reasons. Okay, so you have your statements and then the reason is why you can say that. In a flow proof, you make like a flow chart, so you have like boxes that you write stuff in and you draw arrows and it can get kind of confusing. And then paragraph proofs require, you know, sentences and grammar. We don't want any of that in math class, right? So we're going to use the two-column proof. I think it's the simplest proof to use. So having said that, anytime in your packet that it says paragraph or flow proof, just write a two-column proof. That's the only proofs I'm going to make you do. Okay? Now, you always start with the given statements. So I have 1, 2, 3 given statements. So these will be the first 3 lines of my proof. Okay, so my first statement is GH is congruent to KJ. And my reason I can say that is because it was given. It was told to me. Okay. And then I always label them GH, KJ. Okay. My second line, HJ is congruent to JL. Again, that's given. HL, that's a typo. Sorry. There's no HJ. HJ would go across here like that. That should be an L. Okay, that's given. So these two are the same. And then finally, I have L is the midpoint of GK, also given. Okay, so out of your proof, you've got 3 lines already done because you were told those 3. Okay, no matter what proof you're writing, you should always get the given statements because they're given to you, right? So when I grade a proof, if it's like a proof that I could solve or write in like 5 lines, it'll be worth 5 points. And if 2 of those lines are given, that's 2 free points out of the 5. So always, at the very least, write the given statement down. You at least get some of the points, right? It's part of the work. All right, now, we've got our given statements. And I labeled the congruent sides. And I'm just going to say L here is a midpoint. And I know I'm trying to prove this triangle is congruent. And I'm trying to prove it's congruent by side, 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 or side, angle, side. So I need something. I have 2 sides. That's good. I've got 2 sides. So I need to either prove that this angle is congruent to this angle, or that this length is congruent to this length. I need one of those to be able to have side, 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 or side, angle, side. the statements I have been given will give me one of those. Can anybody hazard a guess as to what would give me that? No? Okay, let me give you a hint. When you've been given statements, one of them will give you kind of a, well, what does that mean? So it will take you to the next step. So two sides are the same length doesn't really tell me much of anything. It's just, okay, this side is the same length as that side is the same length as that side, okay, fine, whatever. But midpoint. Midpoint means something. Anybody remember the definition of midpoint? It's the middle of the line, right? That tells me that GL is the same length as LK. That's the definition of midpoint. Okay, so you'll be given some statements. And then the next step is you either define something, you might have to add, subtract, multiply, or divide something. You might have to substitute one thing for another. Or you might have to introduce something, say, for example, a common side or like maybe vertical angles, something like that. But usually definitions are one of the most common thing that pops up. Our definition of midpoint, we were told a midpoint, and the definition of midpoint tells me that this is in the middle, so this length is the same as that length. I now have my side, side, side. And so my last line is triangle GHL is congruent to triangle KJL, side, side, side. This prove line will always be your last line. So givens will be your first line, prove will be your last line. You have to come up with the reason, and then you'll have to fill in a couple lines in the middle. With triangle proofs, usually one or two. In the past, I've had you guys do this with the distance formula. I'm going to show you now how to do it without the distance formula. Okay? I'm going to label the points for D, E, and F in blue. And I'm going to label the points for P, Q, and R in black. Okay? So let me just make this a little bigger. Okay, so D is negative 6, 1. E is 1, 2, and F is negative 1, negative 4. Okay, that's the first triangle. I'm not going to connect the lines. P is 0, 5. Q is 7, 6. And R is 5, 0. Okay. Now I want DE to equal PQ. I want EF to equal QR, and I want DF to equal PR. Okay, and I'm just doing that from the order of the triangle letters and the names. Now the distance formula comes from Pythagorean theorem, right? Triangles. Okay. If I were to connect these, it makes a right triangle. Do you guys see that? So if I count, so this was D, oops, I should probably get out of shape recognition. Okay, this is D, this was E, and this was F, and this was P, Q, and R. So if I count from D to E, it's up 1 over 1, 2, 3, 4, 5, 6, 7. So I went up 1 over 7. If PQ is the same length as DE, it'll be the same distance along the legs of the right triangle to make the hypotenuse the same. So I need to be able to go up 1 and over 7. These are the same length. Okay, now I want EF, E to F, and Q to R. So to go from E to F, I go down 1, 2, 3, 4, 5, 6, and over 2. So far, so good? So to get from here to here, I need to go down 6 and over 2. And I did 1, 2, 3, 4, 5, 6, over 2. So this length, EF and QR, are the same length. Does that make sense so far? If not, let me know. Okay, finally I need to know the length of DF and PR. I'm not finding the actual length of the sides, I'm just finding that they're the same. So I'm going to count from F to D, and I go over 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5. So I have to do the same path, 5 and 5. And I'm at 5 to 0, and then I go up to 5, so it is 5 and 5. So they're the same length. So yes, triangle DEF is congruent to triangle PQR because the sides are all the same length. Okay, so again, I need DE to equal PQ. EF needs to equal QR, and DF needs to equal PR. Okay? So I'm going to find the distance of each of those. So the distance of DE, there's x1, x2. So I have -7 minus -4. y1, y2, so -3 minus -1. Minus a negative is a positive, it's happy. So I have -7 plus 4 and -3 plus 1. So that's -3 squared plus -2 squared. So that's 9 plus 4, so that's the square root of 13. Now you don't need to figure out a decimal answer. The square root of 13 is fine, and then I can just find out if the other length is also the square root of 13. So now I'll do PQ. And that's 2 minus 5. And -2 minus -4. And that's happy. So it's positive. So I'm going to have -3 squared plus -2 plus 4 is 2. So I have 9 plus 4, which is the square root of 13. So these sides do match. Questions so far? Yeah. We have to go through and do all of 6 of these if you're going to do distance formula. Oh yeah, you can choose the distance formula or you can choose the graph paper formula. Yeah. I just want to show you both ways so that maybe if you don't have graph paper handy, you might remember you can do this one. Okay, next I'm going to do EF, which is -4 minus -2 plus -1 minus -5. Do you have to write out all these steps? No. If you can do this in your head. So like for me, I can go, okay, negative 4 plus 2 is negative 2 squared is 4. So if you are able to do that, you don't have to write every single step. If you're not able to do that, then that's fine too. You can write the steps. I would write this part out first, just because of the minus negatives, to make sure you got the sign correct. And then you could go from here to the answer. Yeah. And then I have negative 1 plus 5, so that's 4. So this is 4 plus 16, so this is the square root of 20. So that was this one, and now I need to do QR. And QR is 5 minus 0, and negative 4 minus negative 5. So that's 5 squared and 1 squared. So that's 25 and 1. So that's the square root of 26. These don't match. If you get one set of sides that don't match, you do not have to calculate the third sides. We already know that they're not congruent. So there's no point in seeing if the third sides are equal or not. There's really no way to, or sorry, no reason to do it. So at this point, you just say not congruent, and you're done. So if the sides continue to match, you have to check all 3 sets. But if you get one set that doesn't match, you can stop. Does that make sense? All right, we are not writing a flow proof. 2 column. All of our proofs are going to be 2 columns. So no matter what you see, we're doing 2 column proof, okay? So to start our proof, we make columns. I want to make mine column better than that. Give us more room. Okay. The first column is always statements. The second column is always reasons. Now, when you're doing your proof, if you get stuck, and maybe you can think of like, I know that this line is the same length as this line, but I can't remember why I know that. Put the statement in and leave the reason out. It's, just keep progressing. Okay, just do as much as you can do, because the more you can do, the easier it will get to finish the whole thing. Okay? So we have given. I have 2 given statements. I have RS is congruent to TS. That's given. And it's already labeled right here. So that was my first line. My second line is V is the midpoint of RT. Okay. Midpoint. That tells me what? It's in the middle, so that means RV and VT will be the same length. So that's the definition of midpoint. And at this point, I have 2 sides. I need 3. Well, what do I know about VS? Just, looking at the picture, what do I know about it? It's on the same line, right? So both triangles are sharing the same side, which means it's the same length. But we have to put that in there. Remember I told you about that reflexive property where one thing is equal to itself? And the only thing it's useful for is introductions. Like, hi, this is Tabitha. She's equal to herself. That's kind of what this is doing. Like, we use the reflexive property for that very thing. We bring something new in that hasn't been mentioned before and say, hey, look at this pen. It's equal to itself. Now I can use it. Yay. It's just a logic thing that math requires. You can't just throw VS in there and say something about it without it being introduced. So we introduce it. And we introduce it by saying VS is the same as itself. And we call it the reflexive property. So anytime a point or an angle or a side of a figure needs to be introduced, you just say it's equal to itself and call it reflexive. And then you can use it for anything else in the whole proof. Okay, I know it's silly, but it's the way things do work. It's just how it is. Okay, so now I have 3 sides. And so my final statement side, side, side. Any questions on that proof? In this proof in the last proof we did, we only introduced 1 line. We defined midterm. And in this one we defined midterm, but then we had to say, hey, here's this other side that's itself. Yeah. Reflexive. Yeah, it sounds like reflective, but it's reflexive because they had to name it something different because they're mathematicians and they're weird that way. When we're talking about side angle side, we're talking about an included angle, and the included angle is the angle between 2 sides. So if I have a side and I have another side, this is the included angle in between. Okay, and so we have side angle side congruence, which said if 2 sides and the included angle, of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. Okay, so if AB is congruent to EF and BC is congruent to ED and angle B is congruent to angle E, you have side, angle, side, and the triangles are congruent. All right, so given AD and BE bisect each other, and then you prove the triangles are congruent. So my given statement what does bisect mean? Cuts them in half, yeah. So if I cut, these are cutting in half, right? That means this side is the same as this side, and this side is the same as that side. That's what bisecting means. So now I can say that AC is congruent to CD, and BC is congruent to CE, because that's the definition of bisect. Does that make sense? Okay. So now I have two sides, and I either need the third side or the angle in between them. Looking at the picture, which one would you know to be true? That these angles are congruent or that these sides are congruent? The angles, yeah. So what I'm going to do is I'm going to number them, just because that way it's easier to name them in the proof. And you're allowed to do that. You can number the angles so that you don't have to say angle A, C, B. You can just say angle 1. And we know that they're congruent because they're vertical. So you just write vertical angles. Okay. And then I have that the triangles are congruent because of side, angle, side. Okay, determine which postulate, again we're using angle, side, or side, side on this one, can be used to prove that the triangles are congruent, and if it's not possible, we're going to say not possible. Okay, number 4, I know these sides and I know these angles, but does that tell me anything about congruence? I have one side and one angle, but they're not related to each other, so we'll say not possible. Number 5. Got two sides, and then I got a common side. So I have side, side. And then number 6. Side, side. Okay, now this is actually, guys, this is actually a technique that people do use. This is real math, like real world math, to measure the width of something that you can't measure, like you can't take a tape measure across a lake, or in this case a sinkhole or something. So what they did is they draw congruent triangles by making these lines, you know, marking off these lines. And then they measure this distance. And so they're asking you, how do you know that this length is the same as this length? Well, these angles will be the same, so you'll have side, angle, side. So anytime you need to measure the width of something that you can't measure, like maybe you want to measure how wide a tree is, the diameter of a tree or something, you can mark off congruent triangles like that, and then you measure this distance here that you can because it's on flat ground or whatever, and then that tells you the width of whatever it was you couldn't measure. So, that's kind of useful math that you might have to use someday in real life. Okay. Well, I'm going to give you guys homework that you can finish in class because there's only 4 problems and there's only 15 minutes left of class.